All right, so what is cross section? So cross section is not rotation. So I'm gonna say this is not rotation. So that means there is no pi outside. There is no pi outside. So this is not rotation. Okay. So that means if I cutting a carrots this way, like if you take a carrot, you chop this way, what kind of shape are you gonna see?
A circle.
A circular disc, right? A disc, and it depends on how slice you cut. Now that's a circle shape. That's called cross section. Now imagine I have a cross section that I cut, and I got each cut I got a square. It's really hard to visualize that shape. But each cut, each cross section cut is a cross section. It's gonna be a square. So which things that I'm care about is which specific shapes. First one is square. Second is equilateral triangle. And third is a semicircle. Okay, so this is three basic shape. Four is gonna be rectangle, but we probably not gonna have time to get to rectangle. But we have a square, equilateral triangle, semi-spheres, rectangle. So I'm gonna give you a situation. The situation is based on two graphs. Now your homework may be different graph, but this graph, first graph, I'm gonna start with the y equal to square root x. So if I graph that, y equal to square root x is gonna be something like this. So it's something like this. I'm gonna use this as a 1 and this is a 1. So something like this. That is the square root x graph. The second one is going to be y equal to x squared. So this one's going to be something like this. So this is a y equal to x squared. And this is y equal to square root x. There is a distance between the graph. Okay, so we're going to call this d. And this d is the distance. Can you tell me what a d in here defined as in this particular situation? What is the distance between those two graphs? Well, only want a distance. I don't want your integral. I just want a general distance. What would it be?
Formula?
Square root x minus x squared. That's perfect.
Yeah.
Because top minus bottom. Because top is the distance from here to here, right? The bottom's distance from here to here. If you subtract, I'm going to get a d. D is the distance between two graphs. Now, the d is going to be the base of the cross section. The d is going to be a base cross section. So you are going to have something like this. Remember, this is three-dimensional shapes. So you are going to have something like, I'm going to use green. Green like this. So it's going to be something like this. Like this is going to be a square. This is a cross section. It's going to be a square. Now, when you go to here, the cross section is a lot smaller. And here it's going to be smaller. So it's going to be smaller cross section. Now, I didn't do a good job in drawing, so I'm not going to try. So I'm going to erase those things. And I'm going to show you how GeoGebra is going to look. You guys can copy this link if you want, but you just have to search it. If you search it, it's just type in GeoGebra. You go to Google, and you're going to go GeoGebra cross-section. And if you click on cross-section, it says visualize value by known cross-section. Now, I have this graph here. This is square root x graph. This is an x squared graph. Now, this is a sideways, so I'm going to turn this way. This one just looks like the normal graph. Is that okay? Now, I decide to have one slice. So one slice is going to be like this. You're probably going to see anything. But if you tilt this graph a little bit, you see it. That's one slice. It's based on this times itself to form this times itself. Because this is the distance, right? If it's squared, then it'll be d squared. So then you'll have two type of things. So sometimes you have A and B. So either it's perpendicular to x-axis, which is most common, and you got perpendicular to y-axis. Okay, I will change it. Perpendicular to y-axis. So you got two different type. In this case, it's perpendicular to what? It's x-axis. It's perpendicular to x-axis. Now, sometimes you will find the distance between here and here that's perpendicular to y-axis. That's something that you have to do when you read a question. Are they perpendicular to x-axis or y-axis? So there are two different type of perpendicular. You have cross sections perpendicular to x-axis or cross section perpendicular to y-axis. So what you're gonna do is you're gonna go back here. You say, oh, okay, well, what I'm gonna do is I'm gonna click one section and I'm gonna break up as many pieces as possible, 100 pieces. So this will look like this. And if you want to look at small piece, you can see that 20 pieces is gonna be like this. So that means you every time you cut this carrots. Every time you cut, it's gonna be a square. It's kind of like if you have carrots in the Minecraft. In the Minecraft, everything's pixelated. Everything's a square, right? So if you cut it, it's gonna be bigger square, bigger square. So if you cut it, if you cut a big, huge ass carrots in the thing, it's gonna be a square each time. Because they don't have a round. I don't know. I never played Minecraft before. I just seen that before. So I don't know if it's true. So this is a square. Now I never seen any type of structure or species looks like this. But this one I do see sometimes. If I really like this, I don't know, if you look at Sydney Opera House in Australia, the roof, it looks kind of like this. So like it looks like, I don't know if it is or not, but it kind of looks like, remind me of this. Now this looks like a fish or like a things on the floor on a raining day. I don't know what's that called. Leech or no? Leaf? No, it doesn't, because kind of like look like leech. Yeah, well, it could be. I don't know. No. Like a pot or something pot. Okay, so shh. What we're gonna do is, if you wanna find a square, what you're gonna do is you're gonna equal to. Shh. You're gonna say this is equal to integration. Well, d, why d? Well, d is the distance between two things. That's the base of the shapes. Now, if you want to find square, all you gotta do is square, because remember it's side square, right? You could have dx, and this is gonna be a to b if it's perpendicular to x-axis, or, and this is 1 in the front because it's not changing. So, or you could have between c to d of d squared dy. So d represents the distance between two graphs. So d is equal to the distance between two graphs. Now there's no pi in the front, there's 1 here. For equilateral triangle, it's really easy. It's actually square root 3 over 4. You just have to remember the coefficients different. Everything else is the same. A to b, d squared dx, or square root 3 over 4 integration c to d of d squared of dy. D represents the distance. Some textbook use s. For semicircle, it's going to be pi over 8. You have to remember pi over 8 from a to b of the d squared dx. Pi over 8 from c to d of d squared dy. For rectangle, depends on rectangle. Rectangle could be different each time. Rectangle, it says, is the height is 2 times the base. If the height is 3 times the base, then just gonna give it 3. Why 3? Because the base times height, but the height is 3 times, so it'll be 3 in the front. So that's gonna be like this. And 3 between A, C to D. Now this cross section could be in terms of y though. So that's pretty much it. You got this situation today. 1, 2, 3, 4. They can give you says square, equilateral, triangle, square. You just have to find the distance between the two graphs, and then you square them. Do not need a pi in the front, unless it's a semicircle, then you have pi over 8. Some people says, why is square root 3 over 4? I'm gonna give you a fast breakdown of SAT sections. So if you have equilateral triangle, what will happen? This is 60 degrees, this is 60 degrees, this is 60 degrees, right? If you break the halfway, what is this angle? 30, 60, 90, right? And then we know this is side. So this is 90 is facing the side. The bottom must be side over 2. Because 30 degrees is facing this half of that. Now to facing the 60 degree is basically this times square root 3. So it'd be s square root 3 over 2. So if you want to find the area is equal to 1/2 base, which is 6 s, and then the height is gonna be s square root 3 over 4, and that's you get square root 3 over 2, and that's equal to square root 3 over 4 s squared. So that's how you get square root 3 over 4. That's a basic SAT questions.
Yeah, the last FAT they had almost no geometry. The questions that were in geometry are very good geometry.
They will ask you a specific shape.
There was straight stuff. There was geometry. I didn't have a single rectangle circle.